Financial transactions have become easier over time. Long back, people used to use the barter system to exchange something that they had for something else that they wanted. And obviously, this was very challenging. With the introduction of paper money, things became a lot easier, and this led to more transactions being done. But there was still this problem that you had to carry cash around and then go to the bank to withdraw more. And with the introduction of debit cards and credit cards, this problem was also solved, and the financial transactions became even more easy. And this led to more of them getting done. And now it's become even easier that you can just tap a phone or a smartwatch on a reader and a financial transaction gets done. Unfortunately, the same is not true for security remediation. Historically, security tools tend to find issues and then point towards documentation for the fixes. And so the developers are expected to read through the documentation, figure out what the right fix should be, and then implement it. And this means that there is a learning curve to implement the fix, and one has to experiment a bit to figure out whether the fix is really going to work or not. And this causes frustration. And as a result, not a lot of security remediation gets done. So here we can learn from the financial industry that if we make remediation easier, then more remediation will get done. Hi, my name is Varun, and I am the CEO and co-founder of StepSecurity, which is an open core startup that helps developers defend against software supply chain attacks by automating security best practices. And the title of my talk today is Security Checks Simplified: How to Implement Best Practices with Ease. So what we'll do today is look at the OpenSSF Scorecard tool, which is a tool that finds issues across the software development lifecycle. We'll then try to fix these issues using manual remediation and look at what are some of the challenges. And then we are going to look at some strategies and techniques to automate these fixes and see how that makes it easier to get a higher score. Throughout this presentation, we'll use a demo repository where we'll start off with a low score and then use automation to fix the checks, to implement the checks and get a higher score by the end of the talk. So the scorecard tool is from the OpenSSF, which stands for the Open Source Security Foundation. The tool itself assesses projects for security risks through a series of automated checks. Now, even though the initial intent was to run these on open source projects, a lot of the checks also apply to private repositories. And since a lot of open source projects are on GitHub, a lot of the checks work well on GitHub, but there is work being done to port the checks to GitLab and other source code management platforms. So now let me go through the different categories in which it finds these issues. The first one is code vulnerabilities, where it checks whether the project itself has known vulnerabilities or if one of the dependencies has known vulnerabilities. The second one is maintenance, where it checks if there is a process in place to update dependencies to the latest version. The third category is continuous testing, where the tool checks if basic security tools are being run as part of the CI/CD pipeline. The fourth category is source risk assessment, where it checks the settings on the repository itself, things like branch protection and code review policies. And then the last category is build risk assessment, where it checks whether security best practices are being followed for the CI/CD pipeline. So as you can see, the checks are across the different components, the source repository itself, the code and the pipeline within it, and also the dependencies. So now let's look at a few demos. First, we'll start with a look at the OpenSSF Scorecard project, and then we'll apply and run the tool on a demo repository. So this is the GitHub page for the OpenSSF Scorecard tool, and you can check it out to see how these different checks have been implemented. When you use Scorecard, you get a score which is from 0 to 10, and you can also add a badge to your project. In this case, you can see that the Scorecard tool or the project has a badge for itself and has a really high score of 9.6. And then you can scroll down and look at, go to the README page. I think I'll just stop at where it mentions the goals, which are to automate analysis and trust decisions on the security posture of open source projects, and also to use this data to proactively improve the posture of critical projects that the world depends on. So in this case, we are going to be looking at the second goal where we have a project and we are going to run Scorecard on it, get a score, and then improve the posture of that project. Next, let's see how you can run the tool on a repository. So in this case, I'm using a Docker image published by the Scorecard project and running it on a demo repository, which is this Spring Pet Clinic repository that I've created, where the code comes from a popular sample. You will also notice that this is using a GitHub auth token because some of the checks require looking at the repository setting itself using the GitHub API. So you need to provide a token for these checks to run. So here it's running these checks and it's going to soon print out the output. So let's look at the output. Here you can see that the aggregate score is 3.6 out of 10. So that's our starting score. And then it goes into details about why that is the case. So our branch protection is not set up, so we have a 0 on that. There are no code review policies. There is no dependency update tool that's been set up in this repository. And then if you look at pinned dependencies, looks like some of the dependencies have been pinned. And so we have a score of 9 on 10 there. There is no static analysis tool which is being run, so there's a 0 there. And then finally, token permissions have not been set up on the GitHub Actions workflows, which is why that was also 0. So that was a quick demo of running the tool on a repository. Now we'll look at another way to run the tool on a repository, which is by adding it to the CI/CD pipeline. So in this case, Scorecard is being run in a GitHub Actions workflow, and there is this Scorecard action which is published by the project. And with this, it runs as part of the pipeline. So anytime there is a pull request or anytime there's a change to the branch protection, the same Scorecard tool runs and uploads the findings in the code scanning UI. So in here, you can now see the same findings that earlier we saw in a terminal. You can see them in this view. So that was a quick demo of running the Scorecard tool on a repository. And as an output, as we saw, our current score is 3.6. And we have a lot of work that we need to do in order to improve this score. So we need to set up branch protection so that we can then set up policies for code reviewers. And we need to set up a dependency update tool so that dependencies get updated as there are new versions that become available. We need to pin dependencies because if you don't pin them, then it basically means that whenever the dependency has a new version, it might just use the latest version and you don't get a chance to review if that latest version is going to work well or not. We then need to declare the least privileged CI/CD tokens, which is something specific to GitHub Actions workflows. and we need to set up a static analysis tool. So in this next demo, we will try to do these things manually and then look at what are some of the challenges. So in here, we are back to that demo repository, Spring Pet Clinic. And now the goal is to try and implement these fixes manually. So so if we look into branch protection, this then points us to documentation. And then in order to set it up, you have to go through this documentation, learn about it. But then there are a lot of these different options that are available that you need to know which ones to set to get a higher score. And then, this is where you can actually go and set up branch protection through the project settings. And here you see those actual settings, but this involves a lot of clicks. And it also is something which can only be done by an administrator or someone who has the right access level to set up branch protection, which means that if you have to do this at scale across a number of repositories, you might have to reach out to someone else who is an admin and ask them to set it up. And this again causes a challenge and makes it harder to do. So here, we're just setting some options, and we will later do this in a more automated manner. So now that we've looked at branch protection, let's look at a few others, right? So now we're going to look at setting up a dependency update tool. And here again, if you see that the way to fix it is that there is certain documentation and you have to go through that. So in this case, let's say if you want to use Dependabot to do these updates, then there is another configuration file that we need to learn about, right? And there are these several settings that apply to it, which are different depending on what package ecosystem you want to use. And you may be using multiple ecosystems in your project. And so this again becomes the same problem, right? That you have to go through documentation, read through it, figure out what the fix should be before you can apply it. So there are a lot of manual steps involved here. Next, let's look at setting up token permissions. And that then points to another set of documentation where you can see that, there are a whole set of permissions which can be set up, and there's a particular way of doing it. But now you're not sure what permissions does your workflow really need? And if you get it wrong, you might cause the workflow to break. And if you just give all the permissions, then it doesn't really help either. And, your score will not really increase. So that's another example where you need to look at, the documentation, figure out what the fix should be. Then there's pinning of dependencies, where there's again a set of documentation. You look at an example of how to do it. You can see that you need to get the commit SHA for a tag and set it in a certain way. And then finally, there's about setting up an SAST tool where there are a few options. And, for each of them, again, there's additional documentation. And so as you can see that, going through this process and doing this manually involves a lot of steps, and it might actually involve reaching out to others in the organization who have the right level of access to do some of these things. And this is where it gets challenging. And so now let's look at how we can automate these steps, and what is our overall strategy going to be for this. And that is basically to list down all of the steps that are in the documentation, and then try to see if we can eliminate steps in some way. And if we cannot eliminate them, then we try to automate these steps. And this is just a general work simplification strategy, which has been applied in a lot of different domains, where you list down the steps, try to eliminate the steps, and if you can't eliminate them, then try to automate them. So we're going to apply this strategy to these different checks that had to be fixed manually. And then let's see, how we can go about doing this. So the first thing that we're going to try to solve is branch protection. And to do that, a common strategy which is being used is to use GitOps to manage repositories and to set up branch protection. And GitOps is basically has these three components where the first one is infrastructure as code. So you declare your infrastructure as code and you have this a single source of truth for that in a Git repository. And then if you want to make changes to it, you do that using a pull request. So let's say if I want to add a repository or change a repository, instead of going and doing it through the UI, I would then create a pull request in this repository where I've declared the repository settings as code. And that gives an opportunity to review the changes and run CI tools on it to make sure that the changes are appropriate as per the requirements of the organization. And then once that is merged, the third part comes in, which is the CI/CD, which will actually implement those changes or publish those changes to the repository. And so you see this concept of a declared repositories where they're declared using code, and then whenever changes have to be done, that code is modified and those changes get done. So this has a lot of advantages in the sense that it makes the whole workflow easier and faster. You can enforce standards using CI tests. There's a clear audit trail of who made the change and who approved it. And you can delegate these changes. So you don't need everybody to be an admin or have high privileges in order to set branch protection or create a repository. But you can actually delegate it because there can be different people who create a request or a pull request for it and a different person who approves it. And so this is actually being followed by a lot of projects. One particular reference that I want to share is Peribolus, which is from the Kubernetes team, and they actually use GitOps to manage their repository, especially the areas around adding new users and managing teams in different repositories. So now let's look at a demo where we are going to set up branch protection for our demo repository using GitOps. So in here, what you see is a separate repository with the name GitOps, where I've set up infrastructure as code for our demo repository. So if you look at here, in this case, I've used Terraform in order to specify the current state of the repository. So here you can see that the repository name Spring Pet Clinic is specified and the description is specified. And this is how I actually created the demo repository. And now what we want to do is to make a change to it in order to set up branch protection. So what I'm going to do here is to add more infrastructure as code, which is specifying what are those specific things, the settings that need to be set up for branch protection, what are the required status checks, and so on. And this I've selected in a way that gets us to a higher score from Scorecard. And now what we're going to do is that we're going to create a pull request. And when that happens, we can then run different CI tests on this. So your organizational policy might be that you need a minimum of 2 reviewers, and that is something that can be found using a CI test. And so in this case, we have a workflow where we are doing basic linting of this particular of any changes that are being made. And then, we are using Terraform to publish a plan so that we know what are the changes that are going to happen. We can also see these changes as a comment in the pull request. And this is basically how the workflows have been set up. And now I'm going to go ahead and merge this pull request. Now, in a real scenario, it would be someone else who reviews it and merges it. And when this happens, now a CI/CD would run to actually apply these changes to our repository. And so this is where it's going to actually take the admin credentials and apply these changes. And this is where the branch protection is being set up. So once this finishes, we will actually go and see branch protection being set up for our demo repository. So now you can see here that under settings, under branches, this branch protection rule has been set up, and this got done using GitOps. And here you can see the same settings that were specified there are visible in the UI. So with this technique, it makes it much easier to scale these settings across repositories and enforce policies in an org rather than having a few people have admin access and then doing a lot of these clicks across repository, which makes it much harder. So that was a quick demo of using GitOps to manage repositories and specifically managing branch protection. So now let's see, we're going to run scorecard again on this demo repository. And now that we've fixed the branch protection using some level of automation, we should see an increase in the score. So now if we go up, we can see that our score has increased to 4.2, and the branch protection score has increased to 8 out of 10. And it's still not 10 out of 10 because there are certain more requirements like having a code owner's file, which I didn't go into, but that's still a great improvement in terms of score. So now that we went through that demo, we can see that our score has gone up from 3.6 to 4.2. We've set up branch protection. We've set up a code owner's code review policy. And so we've done a couple of things, and we saw how this was done using automation, using GitOps. Now, the next thing that we need to do is to fix the rest of the issues, to set up a dependency update tool, pin dependencies, declare least privilege tokens, and set up a static analysis tool. And to do this, we are going to use code from this repository or this project called Secure Repo. And Secure Repo is something that StepSecurity maintains, and it is a set of automations that help you transform a source file from one state to another. So for example, if the minimum token permissions have to be set up, there is code in there which takes a CI/CD pipeline file, analyzes it, and transforms it into an output file which has those permissions set up. Or when dependencies have to be pinned, again, it has logic to take in a file as an input and then has transformation logic to convert that into a output file which has those dependencies pinned. And so next, let's look at a quick demo of the Secure Repo project and see how we can use it to improve the score via automation. So this is the GitHub project for Secure Repo. It's an open source project. And to start with, let me show you the design from the tests, looking at the tests. So if you see, the tests are organized using this input and output folders, where the input has what are the expected files. And here, for example, you can see that this is what a workflow looks like, and it has a V1 tag. And this is something that it's going to transform, and the corresponding expected file is in the output folder. And this is how it's expected to be. So similarly, for setting up the right permissions, again, there's this input output folder, and the input has the expected files. Let me just go back. So in the input folder, there is a workflow which is missing the permissions keys. And then in the output, it has the actual permission setup. So this is, what I'm trying to show you is how the test cases are organized, because with that, you get an understanding of what it is trying to do. It's essentially just trying to transform a file from one state into another. So from a state where it doesn't have the fix applied to a state where the fix has been applied. And so now let's look at some of the code that does this transformation. And I just want to, go over it at a high level because you can always go back and look at this code. So in here, let's look at how it does pinning of actions. And in this case, it takes the YAML file as an input. And then for each of the jobs, it tries to pin actions. And then the way it pins that action is by getting a commit SHA for that action using a GitHub API call, and then replaces it with in place of the tag which was being used. And in here, we can look at how it does, it sets up permissions, and which is again similar in the sense that it basically tries to do what a human would have done and just automating those steps. So it looks at each of the jobs in a particular workflow and then tries to calculate a permission for the job. And it does that by looking at each of the steps in that job and then by trying to calculate the permission for that step. And then it adds all the permissions up, and the permissions for each step or for each action are actually stored in a knowledge base. So there's this knowledge base in the repository which has information about a lot of common actions that are being used. So in this case, this is for the create release action, which requires contents write permission. So all this information has been curated, and then it's used to, the algorithm uses to add these permissions up to come up with an actual answer. And so if a human had to do this, it would take a lot of steps, a lot of learning involved in terms of what are the different permissions needed for different actions. Now in here, we are looking at the code that adds a certain workflow, like a code QL workflow or a different tool into the repository which is getting fixed. And for that, there are templates which are stored in this repository. So it takes a template, looks at what are the languages that are being used by that project where the template needs to be applied, and then sets those languages in there, and then outputs a workflow which is specific to that repository. So that was a quick demo of the secure repo project and how is it organized. And next, let's look at how we can use secure repo on our demo project. So in here, what we're going to do is we're going to try to fix the issues in our demo project using secure repo. And the way this is done is that secure repo has a hosted version, and Scorecard actually points to it for remediation. And that is to make it easier for projects to get a higher score. So if you saw there was a link going to the hosted version of secure repo. And in this case, it basically pulls the file because these are open source projects. It can just pull the source file, does the transformation. In this case, it has pinned the actions to a particular commit SHA. And now the maintainer of the project can just copy this file and paste it back in their code editor, or just create a pull request using it. And with that, this pinning gets done. So it basically cuts down on a lot of steps involved by automating them by using secure repo. And then what it can do is it can even go further so that you don't have to do this for each file. And you can here see the concepts being applied where, you are reducing the steps at each stage. So instead of having to do this manually every time, another better option which is available is to create a pull request. So in here, you can go click on pull request. And in here, I'm actually putting in the repository, the demo repository, and clicking on analyze repository. And then the secure repo project looks at all of the things that it can fix. And this is something you can just try right now on your open source projects if you have any. You see all of the ways in which you can fix them. You can unselect things if you don't want a certain fix, and then click on create a pull request. And you don't have to set up any app for this. It just uses a fork to create the pull request. And Now you'll soon see all of the changes that are being made using this automation. So in this is a pull request that got created on our demo repository with a list of all the changes. And in here, you can see that a Dependabot configuration file has been added. So, it figured out that these are the different ecosystems being used by this project. And so it's suggesting those. And then it has added a CodeQL file, with the right language set up, which, so detected it has using Java. So it set that up. And then for an existing workflow, it set up the right set of permissions that it needed. And it has also pinned this dependency. So it essentially cuts down on a huge amount of steps that one had to follow in order to make these fixes. And now once this pull request is merged, we can actually go ahead and see the change in the score. So in here, what I'm going to do is that after merging that pull request, I'm running scorecard again on our demo repository. And this time we have a higher score. So now the score has increased to 6.3 out of 10. And if you see, compare it with where we started. So now we have a higher score in branch protection. We have a higher score in the dependency update tool because the Dependabot configuration got added. So we have a 10 on 10 there. And in terms of pinning dependencies, because those got done via automation, we have a score of 10 on 10 there. A static analysis tool got added, so we have a score of 8 on 10 there. And then the token permissions were set up, and so we have a score of 10 on 10 there. So overall, with this automation and by using secure repo and doing the changes using automation, it was much easier to apply these fixes. And now, our score is 6.3. And if you see in terms of the automation status, all of these things have been done by a high degree of automation. And that's why a lot of projects are actually able to increase their score, from a low score to a higher score, just by clicking on a few buttons to create a pull request and, by managing their repositories using GitOps. And so to summarize, in closing, I just want to reiterate that, historically, security tools tend to find issues and then point to documentation for fixes. And if these documentation, if this can be automated, if each of the steps can be automated, the remediation can be made much easier. And when that happens, a lot more remediation will get done. And from a more practical standpoint, you can actually use the scorecard tool to understand the state of your projects. And then, in terms of automation, you can consider using GitOps to manage repositories and the secure repo project to help with this automated remediation. And so that's all I had for the talk today. And here on the last slide are some references, some projects that were discussed during the talk. Thank you.